So today we're going to write a polynomial function of least degree with integral coefficients with zeros of 6 and -4. So let's look at what's involved with this. A polynomial function will be a function of x is equal to, and it usually is, x squared or x cubed or x to the fourth and all the things that come after it. Of least degree will means that when we use these zeros, it will be the least exponent, large exponent. In this case, because there's two zeros, we know it has to be x squared. Integral coefficients means no fractions or decimals. So integrals can be negative, integers can be negative or positive. We know we have these two zeros. Now remember what that means on a graphing basis is that if here's 6 and here's -4, and there's only two of them, that means we have a parabola that goes like this, or it might be going like this. We don't know if it's going up or down, but we know that it crosses the x-axis at -4, and it crosses the x-axis at 6. So what we do to this is we go backwards from the way we find the zeros. Originally, you had some kind of polynomial like this. The function of x equals x squared, let's say plus 2x minus 2x, say, and then plus or minus 24. So if you factored this out, and we would have x, and we'd figure out what two numbers multiply to -24 and add up to -2. Well, that looks like a -6 and a +4 would do that. And then we would take these, we would do this, we would then say, well, it equals 0 because it's the zeros. So we say each one of these has its own 0, and then add the 6, and we get x equals 6, and subtract the 4, and we get x equals -4. Now, notice something. Those are the two numbers we have here. So the polynomial started off as x squared minus 2x minus 24. If you factored it, separated it, and making them equal to 0 because of the zero product property, and then solved for x, these are the x's that, because it was equal to 0, it makes this polynomial function 0. So if I did f of 6 and put 6 into these spots, I'd get a 0. And if I put -4, just said function of -4, and I put -4 in here, I would get 0. Well, this is how we got to it. Let's see how we go backwards to make that. All we really do is the exact opposite. So I could go so far as to actually say, well, x equals 6 and x equals -4. Oops, let's put that negative in there. Now I'm going to subtract 6 and do x minus 6 is equal to 0, and add 4, and I'll do x plus 4 is equal to 0. And remember when we did that, that came from the parentheses being equal to 0, so I would do x minus 6 and x plus 4 equals 0. Notice it's simply the opposite sign. And because we had to subtract 6 to make it 0, it's just the opposite sign that's in the parentheses and the opposite sign here. That means that when you understand what's going on here, you don't have to write this and you don't have to write this. You can go straight to putting them into parentheses if you remember that you have to change the sign because of that reason. So here's where we are now. Well, before we had this and we had factored it to get to that. The way you go back from this to here is you multiply it. So we're going to distribute x times x is x squared plus 4x minus 6x minus 24 is equal to 0. And we have two like terms we can combine. X squared minus 2x minus 24 is equal to 0. This is not in function notation yet. So the reason is because we were finding out what the zeros were, so we made it equal to 0. We no longer are finding out the zeros. We want the function, so we just simply don't use the equal 0, and instead we use the function notation. This is the function that uses these two zeros. There are others that would too, but this particular one we know for sure does indeed you have these two zeros for it. And so that would be the answer in the way that it should be written as well. let's look at a second problem that has a different twist to it. We are going to do the same thing here, but we're going to do it with an imaginary number. Because remember that some things have imaginary numbers. So in this case, if we were graphing it, we're crossing at 2. But with an imaginary number, it means that part of the graph, it only touches it here at this one time. So that means the graph is probably like this, where there's another curve in it, but it never comes down and it reaches the x-axis. So only in one place does. There's only one real, actual 0. But there is an imaginary bit, 0. And that brings up a couple of issues. So what that is we have 2, we have negative 3i, but we also have positive 3i. Always, 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 imaginary numbers come in pairs. That means that if there is a negative 3i, there has to be a positive 3i. So opposite sign, but the same number otherwise. So if this had been positive 7i, we would have had positive 7i and negative 7i. Anytime you see an imaginary number for this context, you always include its conjugate, the opposite of it. And what we now do is what we did in the last problem. Use the opposite sign, so that's x. Now that's x, whoops, I put plus, it should be minus a plus, so let me just rewrite it. I'm going to change the sign. This is x minus a negative, which means x minus a negative is immediately x plus 3i. And this one's x minus a positive, so it's simply x minus 3i. And that was equal to 0. We don't really need that anymore, but that's the reason that we had done it, is because we're going backwards and we had to make it 0 in order to get these. Well, now we're going to multiply these. And there's a little trick to make it slightly easier. If I wanted to multiply this times this, I can do that, work it all out, and then multiply that times this, and I can do that. But there are a lot of steps involved, and it's very possible to make a mistake in there. It's always possible to make a mistake, but the less steps you do, the less chance you're going to make a mistake. So let's do this in a way that has less chance of a mistake. This meaning less steps. This combination, when you look at it, it's the same exact variables and numbers, except that this one's plus and this one's minus. That should remind you of the a minus b times a plus b combination, which when you multiply it, a times a is a squared, and I get plus ab and minus ab, that cancels out. Then I get negative b squared, a squared minus b squared. That comes from this, or if you had this, you could factor it into that automatically. Well, we don't have this. What we have is this. A, the x and the x count really as the a, and the 3i counts as the b. Here it's plus the 3i minus the 3i. That's like plus b and minus b, which means that's really a squared minus b squared. Now, knowing that, I don't have to work out every part of it, but I'm going to anyway. X times x is x squared. This is minus 3ix, and this is plus 3ix. And then it's negative 9i squared. 3 times 3 is 9, plus minus makes negative. I times I makes I squared. Oh, error, common error on doing these problems. Oftentimes people do this and forget to square the I. They don't remember that this one times this one means 2 of them, so they have to put the square. Don't forget that. With all the other stuff going on, sometimes it's easy to forget a little detail like that, but it makes a pretty big difference. These two just cancel out. They're just gone. So they're gone, and this is where you remember what you learned before. I squared is negative 1. That's because square root of negative 1, or square root of negative 1 is equal to I. Well, if you square this, then you're squaring that, and the square and the square root cancel, so we get I is equal to just negative 1. So, if that's negative 1, I got negative 1 here, then negative 1 times negative 9, in fact I'll put negative 1 underneath it, negative 1 times negative 9 is plus 9. So let's rewrite it. X minus 2, and x squared minus and minus is plus. plus 9. Much simpler. This becomes x squared plus 9. You don't even have to write the middle if you really know what you're doing with it, but be careful. Just make sure you're really careful, but especially be careful with the fact that you're always going to have a negative here, and then you're going to have I squared, which will change the sign and make it positive. And that would be equal to 0. Now, we want to multiply this out just like in the last problem. X times x is x cubed. This is plus 9x. This is minus 2x squared, minus 2. And minus 2 times 9 is negative 18. Now, I would normally just do f of x in front now, except that this is not in standard form because we're not going down in order by exponent. So these two have to switch. So the function of x is equal to x cubed minus 2x squared plus 9x minus 18. Now, as always, whenever there are negatives, I want to double check and make sure I really got them right. So I'm going to come back up here and look. Okay, I had the opposite signs, made that positive, made that negative. When I multiplied it, the minus and plus canceled out. Plus 3 and minus 3 multiply to make negative 9. The I squared one becomes a negative 1. These two negatives make it a positive. And then using that negative, that's negative 2x and negative 18. All right, it looks to me like I do indeed have it correct. So the function that has the zeros of 2 and negative 3i, and thus plus 3i, is x cubed minus 2x squared plus 9x minus 18. If we solved this and worked on doing that and found first one of the roots, which would have to be a positive 2 with synthetic division, we would get a depressed polynomial that was x squared something, and we'd have to use the quadratic formula. And when we did the quadratic formula, we would get plus and minus 3i as our answer. And then we would have our three answers. All right, let's do another one. And this one is going to have the I in it as well, and two other complicating things. One of them is it's going to have two real ones, as well as this imaginary one, and of course automatically the conjugate of that. So we're going to have a negative 5i as well. So we have 4. This means this is going to be an x to the 4th power for the least degree, because we have 4 zeros, and that means x to the 4th. This also is a fraction, and I'll show you something about that. First, this was first, that if there was an imaginary number, to put the conjugate. Second is to put them in parentheses with the opposite signs. Now, third would be to multiply these, because I see that this is an a minus b and a plus b combination. But let's talk about this nice little fraction over here. It would be perfectly fine to still work it out with that fraction there, and at some point we're going to multiply that in, and we're going to have some fractions as coefficients. That's perfectly legal, perfectly normal. And we're all good at fractions, but that doesn't mean we like using them. We don't have to use them if there's a way to avoid it, so I'm going to show you a way. Okay? Let's work over here for a second. If we were multiplying this out, in fact, let's take x plus 1/3. That was equal to 0, wasn't it? Well, let's bring that 1/3 over here. X equals negative 1/3. I'm going to bring it back, but I'm going to do this. Multiply 3 to both sides. If I multiply 3 on here, I get 3x. If I multiply 3 on this side, it cancels that out. Now, let's add that 1 to both sides. 3x plus 1 is equal to 0. And if we were doing this as zeros, up here we started as if that was in parentheses. Well, I got down here, and I could do the same thing. I mean, there's nothing wrong with putting parentheses around it. That means, based on what I did here, just subtracting this on both sides, and then multiplying by the 3, and then adding 1 on both sides, these two things are exactly equal. But this is a lot easier to work with, because it doesn't have fractions. And anytime you have x plus a fraction or x minus a fraction, that denominator could simply be put in front of the x as a coefficient, and you don't have fractions anymore, because they're the same if you do that. So let's rewrite it with that. because life will be easier doing that. You don't see this all the time, but if you were to see it, now you know how to handle it. Or at least how to handle it to make it easier for you. Because you could do it with 1/3 all the way through. You're just going to have a lot of fractions to work with. So let's not use fractions, we'll use this. Now let's do this one. I'm going to rewrite these because I'm not using them yet, just keeping them in the pattern. And then x times x is x squared. And plus 5ix and minus 5ix, those go away, and I'm going to multiply these. That's negative 25 and I squared. Well, I squared is negative 1. Negative 1 times negative 25 is positive 25. So I will have x plus 4, 3x plus 1, and x squared plus 25. At this point, and I guess I'll rewrite that to make that clear and neat. And that's a reminder that x squared equals negative 1. So I change that. Well, just for posterity, I should show that what we had here was this. And then that I squared as negative 1 made this a positive. Got it there too. It doesn't matter now what order we multiply. It really doesn't. We can do this times this, or this times this, or this times this. I'm just going to go in order here now. X times 3x will be 3x squared plus x plus 12x plus 4. I'm going to clean this up first by adding those together. 3x squared plus 13x plus 4. Now I can multiply this times these. I mean, we have to multiply this out. I always prefer, if there's a binomial and a trinomial or more over here, to put this one first and use it like I did up this here, using this one times both and this one times both. I want to do this times all three and this times all three. I can do it from the back, but it just visually is easier if I just switch these. This is the same reasoning because it's multiplying these two things. This is all this stuff together counts as one thing, and all of this stuff together counts as one thing. So we have two things. That's like 2 times 3 equals 6. Well, if you switch it, 3 times 2 still equals 6. So when it's multiplying, you can just switch them, and that's what we did here. Now, this is easier in my opinion. X squared times each of these, that'll make that 3x to the 4th power. This one will be plus 3x to the 3rd power. Oh, that's a 13. Oops. Good thing I noticed that. X squared, x cubed, this should be 13x cubed. Okay, be very careful. Notice how easy it is to forget a number, and I'm glad I caught that quickly. But it's always a reason to double check numbers and think about it. X squared times 4x is going to be plus 4. Oh, there's no x there, and I didn't need that anyway. So it's going to be just 4x squared. So good thing I noticed that too. Let's double check each of these numbers that I got. Okay, coming back up here, 3x squared plus x plus 12x plus 4. Okay, that looks good to me. I know that one was right. I worked that out. 13x here, and then needed to write it correctly there. Okay, now it's correct. I'm crossing out that unneeded x. Now, x squared times this just gives me x fourth, x cubed, x squared, because there's no x with that. Now, now what I'm going to do, I don't need it in parentheses. I just did this times those, now I'm going to do this one. 25 times 3x squared, that's 75x squared. I'm going to put it right underneath here, so that I can add those two up more easily. 25 times this, now that's a big number. Okay, that's going to be 250 and 75. I believe that's 325, but I'm going to use a calculator to check since I'm allowed to and don't want to get it wrong. So I'm going to do 25 times 13, 325, so that will be the coefficient times the x. That's going to be plus 325x, and then 25 times 4, which is an easier number to see. Now we will put these all together. There is only one x to the 4th. There's only one x to the 3rd power, or cubed. There are two of them that are squared. That adds up to 79. There's only one that has an x, so we don't need to add that with anything, and the same that has no coefficient. These are in order, 4, 3, 2, 1, 0. I didn't even keep the equal 0 going. That's x to the first power, and there would be x to the 0 here. So we're going 4, 3, 2, 1, and then 0. And that means I can now say that the function of x is equal to this polynomial. One little check, although it's not perfect, but it does tell me that I'm on the right track, is that the degree is 4. That means there should be 4 zeros. And back up here, we had 4 zeros. Once we identified that there was a conjugate for the imaginary number, that gave us 1, 2, 3, 4 zeros. And based on the work we did here, this is the polynomial that results in those 4 zeros. I hope that's helpful to recognize what's going on. In a way, the simple steps on here are the exact same steps that you would do if you have an imaginary number, except that you have to remember to have the conjugate of that imaginary number. And if you have a fraction or more of these, you still do the exact same thing, but handle the fraction like that to make it easier. And then you are able to end up with the correct polynomial for the zeros that you're given.